In this episode, we're going to look at a new Ecoflow power station. This is 300 watts, 600 watts peak, 265 watt-hour battery. This one's called the EFR 600 by Ecoflow. This is the official unbox. We're going to take this unit apart, show you guys what's inside it, and we'll do some charge and discharge testing, go over all the features, and see if it lives up to the claims. So we're going to load this up to maximum power, see what it does, how well it performs, and we'll do a discharge and charge test. So here's the unit in the box. Well, that's the outer box. Here's the inner box. Ecoflow River 2. I reviewed the Ecoflow River 1 last year. This is a more compact, little bit less power version. As you can see, it's factory sealed. So we'll break that factory seal and open it up. And there is the unit. It's compact. It's a lot smaller than the previous model. Again, it has a lower capacity battery. It uses a 20 amp hour 12.8 volt lithium ion battery. 7.8 pounds is the weight. It measures 9.6 by 8.5 by 5.7 inches. It's the model EFR 600. AC input is 100 to 120 volts, 50 or 60 hertz, up to 8 amps maximum. The DC input is 11 to 30 volts, 110 watts, 8 amps maximum, so you can charge it from your solar panels. It has USB-C inputs and outputs, 5, 9, 12, 15, 20 volts, up to 3 amps, so it's just 60 watts maximum. USB-A output is 2.4 amps, 12 watts maximum, and it has a 12.6 volt, 8 amp, 100 watt maximum DC output. AC output, pure sine wave, 300 watts total, surge to 600 at 120 volts or 50 or 60 hertz. It's selectable. It uses a lithium ion battery. They call it LFP, 80% capacity, 3,000 cycles. One of the benefits to this unit is the quick charging time. So it will charge to 100% in 1 hour at 360 watts maximum charge. And we're going to test that. We're going to run this thing down, take it all the way down to 0, and I'm going to plug it in and we're going to time it and see whether it charges in 1 hour. We're also going to take it apart to show you guys the build quality inside and just some of the features it has here. It's a high quality lithium ion battery. And devices output power, 300 watts rated power, 600 watts peak power for most consumer electronics. So we're going to see what this thing will do. And some of the questions that people ask. Can I bring this on an airplane? No, you can't. It's got a lithium ion battery. And for that matter, shipping it is also anything with lithium batteries. You can't ship them through the post office these days because the mail goes on passenger planes. So when you ship something like this, it has to be shipped by cargo because it has a lithium ion battery inside that if it was crushed, well, you could have a bit of a problem. Nice carry handle on it. Here's your inputs on the back, 120 volt input and the DC input for charging, cooling fan, and on the front side we've got your standard 12 volt output, USB-A, USB-A, USB-C, and of course your AC power outputs. If I press and hold the button, we'll see what type of a charge is on here. Looks like it's at 31% is the charge on the battery. We're going to run this down because I want to time it and see how long it takes. So let's power some stuff up and see what we can run through this thing. I'm going to plug my heat gun in on low power, and I should be able to draw 300 watts on here. But I know if I put it into high power, it's probably going to shut it down. But this unit here draws around 600 watts to start, but it should be limited to about 300 watts. So let's just turn it on and see that it does indeed draw 305 watts. And according to this, I can run this, and yes, it is getting warm. It is getting hot. Can't hold my hand in front of there. It's that warm. I am drawing 300 watts, 303 watts, which is right there with what the maximum power is. Let's just take a look at the AC waveform coming out at rated power. So let me turn on my scope we'll take a look at what the AC waveform looks like. We're going to look at the storage scope so we can do some measurements. So this is under no load. So we're at 60, what is it, 60.3 hertz? 60.3 hertz, 123.8 volts RMS is our under no load. We'll put it under maximum load here. Now we're actually in an overload situation now. We're drawing 304 watts, which is over the 300 watt limit. As you can see, the voltage has dropped down to about 89.5 volts, but the waveform stays the same and our frequency remains accurate. So we are not distorting the waveform, we're just getting less power drawing over the maximum output. I'm going to now grab some incandescent bulbs and we'll load it with a couple of 100 watt incandescent bulbs and see what type of load we get. Okay, now I'm loaded. I've got one 100 watt bulb on and it's telling me I'm drawing 94 watts on here, but it's a 100 watt incandescent bulb. I'm going to turn on a tri-light. This is a 50, 100, 150, so this makes it to 150 watts, 200 watts, and 250 watts. And as we can see, the waveform hasn't dropped. We still have 122 volts. And according to the meter here, it is drawing 246 watts. I'll show you the display. Incidentally, these are the incandescent bulbs that I'm running right now. A 100 watt and a 150 watt. And there's 22% battery remaining. And it says it's going to run for 10 minutes. I'm going to try to load this up a little more and get to 300 watts. So let me just add some more load. Okay, this time I've added another 60 watt bulb here, in addition to the 150 tri-light and the 100 watt incandescent bulb. We are drawing 300 watts, according to this, 299 watts. So we're at maximum output, and let's get a shot of the scope. I'm gonna do this in one shot, so you know there's no camera trickery here. The scope is showing that my output is 120 volts RMS, frequency 60.28 hertz. Look at the waveform. That's about as perfect a sine wave as I think you're going to ever see. I'm going to run this for the next several minutes until the battery goes dead, and then we're going to give it a full charge and see how long it takes to charge. So according to the hour meter now, I have 6 minutes of battery life remaining at full output power. As you can see, the input is at 0 because we're not charging anything. If I were to plug in the power while I'm at it, this should operate as a UPS. I believe this one does. Pretty sure it does. Let's just plug the power in the back, just so I can show you guys it will switch over. Fan is going in the back, by the way, now, which it should be. So, see if we can get this to stand up with the power cord plugged in so you guys can see what it's doing. I'm going to plug the AC cord in to power, and we should see the input power should start to show that it's drawing power and charging at the same time. So we plug it in, and now it's kicking in, and you can see that it's charging, drawing a total of 500 watts because it's now charging the battery at the same time as the unit is operating. So the unit can operate as a UPS. Actually, this one's not a full UPS. This is a standby power supply. So when the power fails, it will switch over very quickly to the output. Let's just see what happens when I unplug it. Do we hear any clicks, or does the lights flicker or anything? And it does not. It just goes to full inverter. When the power comes back on, it switches back. I don't know if you noticed the light flicker slightly there when it switched back to charging. We're going to run this down. I'm going to shut off the load, and then we're going to charge it in time and see how long it takes. So it's going to take about 6 minutes now to fully run down the battery. Okay, we've been running for about another 4 minutes here. It looks like there's 2 minutes left. Let's just see how long it will go and what happens when it gets down. We're down to 5% battery life now. So we're down to 2% battery life now. It says less than 1 minute to go. It should just shut off. And then we'll plug the AC power in and it should tell me how long it's going to take to charge. And then we're going to set the timer here on the watch, and we're going to time how long it takes to get to 100%. I'll show you the watch. I'll show you the time when it starts and when it finishes, so we can see if it will charge in an hour as they claim, because the claim on this is it will recharge in 1 hour. So that's what we're going to see. So it should be going off any second. See how accurate the countdown timer is. According to my calculations, it should go off right about now, which it just did. So it's off. The unit shut down. It's telling me that it's there's 0 charge left. We're now going to take the charge cord and I'm going to plug it in. There we go. Wondering why it wasn't starting up. My power cord wasn't seated properly. So here's our charging wattage here. It's charging at 330 watts and climbing. So it's now, if we look at the time, it's now 4:11. 4:11 is when we started, and we're going to see how long it takes for this to charge. I'm going to start my stopwatch going as well. So there we go. My timer is going. Shut off the camera and we'll come back when this gets to 100%. Show you guys how quick it charges, and then we're going to take this unit apart and see how well it's built. What you will notice is it says recharge time is 1 hour. It's going to take to recharge. Once it's recharged, I'm going to discharge this again at maximum load, and then we'll try charging it with the DC input. And unfortunately, I won't be able to. I'll use the DC cord from my power supply. I'll crank my power supply up to simulate a solar panel. I can't charge it with solar panels today because we got a foot of snow outside. There's no sun, so I can't charge it with solar power. But I will charge it from my DC power supply. I have a 10 amp DC power supply. We'll hook that up and we'll charge it with the DC cord. And we'll see how quick it charges, what the recharge time is on that. After I fully charge the battery, run it down completely, and then we'll fully charge it again using the DC input and see whether it charges at the same rate or at what the specs are and how long it takes to charge. So we're at 4%, as you can see already, and it's only been charging for a couple minutes here. Power charging, 100 watts maximum, 3 hours. Solar, 3 to 6 hours at 110 watts maximum for solar charging. So it's going to take 3 to 6 hours with sun to solar charge, 1 hour AC charging. And you can charge with USB-C as well. If you've got a USB-C adapter, this is an input and an output. So you can plug this in to a USB source and charge the battery in here from a USB supply. 5 hours at 60 watts maximum. As you can see now, we are at 12% charge. It's only been a couple minutes, and we're at 57 minutes remaining. It's been charging now for about almost 5 minutes, and it's showing 57 remaining on the display. Alright, we've been charging now for 50 minutes. According to the charge indicator, there's 14 minutes left. We're at 94%, and it's now dropped down to 247 watts as the power drops, as it's getting closer to becoming fully charged. Okay, we're 100%. It just kicked in. 1 hour and 5 minutes to fully charge. If I turn on the AC power, we're now operating in UPS mode. In this mode, the battery will stay at 100% charge. Our input power is 295 watts. Our output power is 295 watts. And we're operating at 118 volts. That just so happens to be the input power right now, because it's operating in standby power mode. So the AC coming in to the power cord is being directly passed to the output. Hence the 295 volts input, or 295 watts input versus output. Now if I remove the power from the incoming power, it will then switch over to operate as a UPS. So let's disconnect it now. We'll notice that the lights themselves shouldn't flicker at all. Everything should stay exactly the same. So let's disconnect power. Just like that. May have seen a very slight flicker as it did it. Certainly not enough for a computer to shut down. It'll switch over very quickly as a standby power supply. And now we have a 40-minute runtime on the battery. So that'll give you 40 minutes to shut your computer down if you're using it as a UPS. Power comes back on, and it switches back over, and now it'll recharge the battery. So it'll operate as a UPS. So we're going to go back to battery power. We're going to time this as well and see if it runs for 40 minutes, as it says. So let's time it. 99% charge now. Let it run, and then we're going to take this apart. And of course, you can see that we're at 120 volts, 60 hertz, and again, the waveform is perfect. Perfect sine wave. 32 minutes in, according to the guessometer, 6 minutes remaining. Remember, it started at 40. So it looks like we're going to be pretty close to 40 minutes when everything shuts down. Down to 2 minutes, according to the meter, and I'm at 36 minutes. So it looks like maybe 38 minutes is what it's probably going to end up running for at full power, 300 watts output. Once it shuts down, I'm going to start up the DC charging, but I want to show the charge current that we're going to draw from the power supply. I'm just going to charge it at 30 volts from my 30 volt power supply, and that should give me a time on here on how long it's going to take to charge from DC. This would represent 110 watt or 100 watt charging from a solar panel of 100 watts, which should be between 3 and 6 hours according to this. We'll also check out the USB-C charging from a 60 watt USB-C adapter. We're at 38 minutes and 20 seconds. It's still operating. It says 1 minute remaining. We'll see how close it was to 40 minutes, which is what it initially said when I started it up. And there we go. So 39 minutes exactly is how long it ran. This time I'm going to connect the DC power cord into the DC input on the back, and that should start the charging of the unit. And here's our watt meter here that it's charging at. It's going to take 3 hours to recharge, and we are drawing at 30 volts. We are drawing 3.6 amps, as you can see here on my power supply. Charging at 108 watts, 2 hours remaining. If I dial down my power supply, so if I drop it down to 12 volts, it's going to obviously take longer. So if I was charging it in a car, 13.8, our charging time is going to increase substantially to 5 hours, because now we're only charging at 50 watts of power. Still drawing 3.8 amps from the power supply. And we're back up to 108 watts. So obviously this is going to be using power from the battery, but we're providing 95 watts, and it will probably discharge the battery. But so we can turn the AC inverter on while we're charging it off of DC, and that was something that wasn't expected. I did not think that we were going to be able to do that, but evidently we can. It's now going to take, however, looks like it's got 10 minutes of run time remaining, because 100 watts at 120 volts is a lot more than 100 watts at 30 volts, so we're going to be losing charge. If we turn that off, it'll charge up. So if you've got a solar panel, for example, plugged in, and you're operating some low, and your battery's charged, for example, right? If you've got a full charge on the battery and you've got solar panels plugged in, you can operate devices on AC, and it will just use power from the solar panels as well as making up for it on the inverter itself. But there it goes, it's charging. We're now at 2%. This has USB-C charging as well, so if I plug it into my USB-C charger, you'll see that it is going to charge at, I think this is a 45 watt charger I've plugged into now. So this is a 45 watt USB-C charger that I'm charging it up with now. That's going to take 5 hours to charge it up from a USB-C charger. So you have lots of options for charging. You can charge from DC input, from the DC input on the back. You can charge it from a USB-C charger up to 60 watts. And you can charge it from AC in 1 hour. And of course solar panels using the DC input, the same as charging it from a car battery, or in this case a power supply. This is a different USB-C adapter. This is only a 25 watt adapter, and as you can see it limits it to 25 watts, which will take 11 hours to charge. This time I'll dig out my 60 watt USB-C adapter and we'll see if it charges at 60 watts. It should go up to 60 when I plug it in. And it does. And in a few seconds it'll figure out that it's going to take 4 hours to charge from a 60 watt USB-C adapter. That's pretty cool. Multiple ways to charge this little unit. I'm liking this. The more I look at this unit, the more I like it. Of course, to turn the unit off, just press and hold. It says off and then it shuts down. So now we need to get into this unit. There's going to be some screws to hold the top on. They might be under these covers. And that is what they are. These are the covers that cover the screws. So pop these out and we'll be in like Flynn. There it is. Here's the business end. Circuit board does have a conformal coating on it. You can see it. It's all encapsulated. That's to prevent moisture, although they still say if you drop it in the water, don't use it. But here is the inverter board, and it looks like it does have a ground. Some of them don't have a ground on it. This one does have a ground on the outlet, which is tied through to the ground on here on the main board. We've got a fuse over here on the input. The battery is below here. I want to see what the battery looks like. What they're using for cells on here, just got to figure out how to open it up. The lights light up on here, indicating there's green lights on here that flash when things are turned on, like power. So power on here indicating that the high voltage is on. Turn that off. To unplug the fan. Okay. Oh, okay. So here's the battery pack. The 12 volt supply from the batteries come up on these terminals here when it's turned on. So if I turn on the power, I'm not going to tear this thing down any further than it is. And the reason for that is because there's no way to really safely disconnect the battery. If the battery was on a plug, there's our 12 volts, right? Oops, I had them reversed. Positive to positive, negative to negative, 12.63. There's 4 large cells. We can see them if we look down here into this holder. There's 4 large, like really large, they're round cylindrical cells. There could be 4 of them. I don't know if you guys can see it or not, but there they are, the blue cells. I don't know what the value on them is. Again, I don't know any real easy way to take this thing apart without, if there was a way to keep this thing shut off. I have to remove these screws here. I took out the screws around the board, but it won't lift. I actually have to take out these screws, which are conductors that transfer the power through from the battery itself. And since I don't have a disconnect on the other ones I've taken apart, there's always been a battery plug that plugs in. I can disconnect the battery, and then I'm sure that the unit is not going to come on. On this one, I don't see any way to do that. Maybe if I disconnect this connector here, this one's soldered down to the board, and this one's glued in place, so I don't want to take that one off. But the unit can turn on, and that's what I'm getting at, is that if I just bump that power switch, I'll energize this board. I don't want to be poking around in there with even though the batteries are discharged, there's still a fair bit of energy in them that could certainly, cause, if something were to short out, for example, we could have a problem here, Houston. So I'm not going to take this thing down any more than this. I'll show you guys the inside. Here's the inside. Yeah, it looks to be really well built. We look at the components in here. Everything seems to be glued down and has a conformal coating on it to prevent moisture. Components all look to be good quality. Yes, I've removed some screws here. Got to put those back in. I thought I could lift the unit out if I was thinking maybe I could lift the entire unit out as an entire assembly, but there must be some screws down below. Like, it almost looks like this whole front should lift off. This whole piece should lift out, but there's got to be other screws securing it. This is attached obviously here to the main board, but I think probably I have to disconnect these terminals here. If we look down on this one, these ones are actually live. They go through, there's metal studs below that secure it down to the battery, and there's probably other screws that hold the battery in place. But for the sake of seeing the battery, I think I'll skip that on this one, just because I don't want to destroy the unit. But if we look how well they've built this, I mean, they've secured all the plugs down with silicone. They've secured down the inductors with silicone. It's got good heavy-duty screws, good heat sinking. Here's our it gets our MOSFETs over here for the inverter, and a bunch more over here for the inverter and the sine wave generator. I mean, this unit really looks to be well constructed, and I'm going to leave it at that because these are great little units, and I'm just basically showing off the operation and how quick it charges and how clean the power was on it and how well it's built, and I think we've covered that quite nicely. So I'm just going to reassemble the unit and then I'll charge it up again. Here's the fan. The fan's easy to replace. Just drops into the back like that, and then this drops into a slot in the back just like that, and the fan plugs in. And that's the only plug that wasn't glued down, almost like it's meant for replacement if the fan itself were to fail. And it has a speed sensor on here, so if the fan wasn't operating when it called for the fan, the unit is going to shut itself down. The build quality looks to be very good from what I can see from looking in to the top, and the fact that you can charge it up in 1 hour is a bonus. So a unit like this would be great to have on your computer, your desktop computer for example, so that if the power were to fail while you're using the computer, the switchover time should be more than adequate to prevent your computer from shutting down in the event of a power failure. This one's not a full UPS, as the other one I reviewed was a full UPS, so the inverter is always running. This one's more of a standby, uninterruptible power supply. So basically, when it's plugged in, it's automatically turned on. So I don't even have to turn it on. Right now it's off, but as soon as I plug in the power, it's automatically going to turn on. So if I hit the AC power over here, you'll see it kick into charge mode immediately. There it goes. If I turn on the AC power, I now have AC power. I don't have to turn it on. So that's the difference between this and a lot of the other ones. Is a lot of the other ones you actually have to turn them on before you can turn on the AC power. This one here, as soon as it's plugged into power, it's automatically on and it's in charging mode, and therefore it is now capable of operating the USB outputs for charging devices, operating the DC output, and of course operating the AC outlet. So that makes it a really nice universal power supply that's ready to go, and if the power were to fail, well, it's on while it's plugged in. If the power were to fail, your outputs would still have power on them to power up your devices. Well, the last thing I didn't show was I didn't show charging USB. So I got my USB-A to USB-C cable. I just turn it on and it will charge my phone. So you can use, but regardless whether it's charging or not, you've got USB output, USB-C output. This will also function as an input for charging, and you can charge 3 different devices at the same time. If I turn it off, when I connect the DC cord, it should also turn itself on. just like when it's done on AC. It should automatically, if I connect up DC, got my power supply on there to simulate charging from a car or solar panel, and there it kicks in. 109, 110 watts, 3 hours to charge. I'm at 6%. And as I say, likewise before, we can turn on the AC outlet. We can also turn on the DC outlet, and of course, the USB outputs will also be live. Anyway, that's about all I can show you on this one. I think we've covered pretty much everything. I'm going to put a link in the description for this Ecoflow River 2. Nice compact, 300 watt, quite light, not huge and bulky like some of the other ones. Actually a very nice compact little unit. I like this one. I like this one. This is a great looking little unit. Thanks for watching. We'll catch you in the next one. Bye.